When somebody says science, what is the first thing that comes to your mind? You might be thinking of something like this, but science might actually be described as the accumulation of knowledge to explain reality and the world around us. This knowledge has been used to build the society we live in today, and improve the lives of people around the earth. In fact, if you went to the site and looked around, probably everything you will see will be the product of science. And there are a huge amount of scientific theories which have been utilised in today's world. Physics has made the world smaller with advances in aviation. Biology has improved the quality of life of millions of people. And evolution has helped us understand how we've come to be today. Charles Darwin, who you've probably heard about on TV or the internet, devoted his life to institutionalising and expanding the theory of evolution. His book, The Origin of the Species, not only changed the world of science but also shaped society as it is today. It has changed the mindset of many people and introduced so many to science. A large part of evolution is phylogeny, where different species are broken up into different groups.
This grouping helps us to compare the relatedness between two species or a group of species based on their common ancestry. This allows for pattern identification and can be a valuable tool for scientists tracing the origin of specific traits and how they developed. For example, recent fossil depicts dinosaurs sitting in a nest in the same posture as birds do today. This indicates independent evolution of behavior in these ancient creatures similar to that of the modern-day birds. However, when phylogeny is used, it becomes apparent that one of the most closely related groups to dinosaurs is that of the birds. A common ancestor between the two must have lived on Earth at one moment in history. The development of the parental behavior, however, was not something which was arrived at by the two groups rapidly. Most of the phylogenetic data shows that this trait developed and evolved slowly and through sequences of evolutionary changes. One of the most vivid examples is that of the evolution of the needed traits for flight, like feathers and light bones. As shown by the picture, it took at least 8 evolutionary changes and millions of years for this to happen. So far, however, we've only mentioned phylogeny and how it actually helps us to classify species and look at historical data. Phylogeny, however, can be used in court cases. One of the recent examples is in 1998 in the state of Louisiana, when a dentist injected his ex-girlfriend with an HIV strain taken from one of his patients. To understand how this happens, we must add some information about the HIV virus. The virus actually mutates extremely fast, which means for a couple of days it can actually separate to several strains. So, by using phylogeny, we can actually trace how each of the strains separated from its ancestral one. So what happened in the case was that they took blood samples from the patient and from the ex-girlfriend. They also took blood samples from several individuals in the population who actually had HIV as well. They constructed a phylogenetic tree and saw how each of the viruses was actually related to each other. So it became apparent that the evil dentist was actually the culprit. He was the one who used the patient's HIV to infect his girlfriend, and in this way phylogeny actually helped to save a case. So overall, as you can see, phylogeny can be used for several means. It can be used to compare derived characteristics or like ancestral characteristics and trace the lineage of several species. At the same moment, it can be used to see how different traits developed through several generations, and as well it can be applied to today to not only science but even social problems like the court case mentioned before.